So far, we have read in a subset of our data and we've renamed our columns. Now we want to start manipulating our data. One of the items from our problem description is that we want to compute the percentage of total Canadian graduates from Ontario. So as part of our cleaned file, we want to create a new column that contains the percentage of graduates from Ontario. And we can do this by creating a computed or a calculated column from a formula. Before we can do this, we need to make sure that we're working with numeric data types in our data frame, right? So remember from last week that each column has a type. So let's check and see if our columns are numeric. How can we do this? Well, remember that we have the describe function. So in week 3, we covered the describe function. And we'll say we're going to do .describe on our data frame and include all of our columns. Let's do that right now. We'll come back into Spyder. And we've been working with grads B in this example. So we will print out grads b.describe, and I will include all columns. And if we take a look here, it looks like we have year, that's a numeric value, but we have NAN for number Canada grads and number Ontario grads. We have NAN for mean standard deviation. That's a clue that we do not have numeric data. Now we can verify this instead of guessing because maybe every single value is NAN. Well, we can also print out the D types, remember? Grads B.D types. Let's print this out and see what data types we're dealing with. Well, year is an int 64, but number Canada grads, number Ontario grads, those are objects. So unfortunately, we do not have numeric data. All right, so we're going to need to clean our data, right? So we need to clean the Ontario and Canada columns. And remember from last week how we solved the issue of having a comma inside each number as our thousands separator? So if we just did 2 numeric and coerced our errors, every single row would end up with NAN. So we're going to use the same process for both columns that we did last week when we had commas. We extract the column, we replace the comma with an empty string, we convert the whole column to numbers, and then we insert our cleaned column back into our data frame. And just for convenience, our renamed columns are going to be year, Canada, and Ontario. That'll just save us a bit of typing. So I'm going to change my column names to be year, Canada, and Ontario. We'll do a final rename at the very end to provide quote-unquote friendly column names. So let's get our data cleaned. So I'll create a new variable called Ontario grads. This is the same thing we did in week 3. And I'll set this to grads B Ontario. So we get a copy of the Ontario grads column. Next, I'll do Ontario grads equals Ontario grads dot str dot replace. And we're replacing comma with the empty string. We'll convert this to numeric. And then finally, we will put this new column back into our data frame. Grads B Ontario equals Ontario grads. And if we run this, look at grads B, Ontario grads is now a number. If you're following along, why not pause the video here and try to write the code that'll convert the Canadian number of undergrads to a number. Pause the video here and give it a try. Okay, hopefully you came up with the following solution. So we extract the Canadian graduates to their own column. We clean that variable, we convert it to numeric, and then we put that column back into our original data frame. So at the end of all of this, you should have 3 columns, year, Canada, and Ontario, all converted to numbers. Again, this is all content that we covered in week 3. But now that we've got numbers, we can create our calculated column. So we're going to create a new column on our data frame, and this is going to be the number of graduates from Ontario as a percentage of all Canadian graduates. How do we create a new variable? Or how do we create a new column? New columns are created the following way. First, we create a new variable which holds a copy of our column. We perform a calculation on our new variable, and then we save this column into our data frame by specifying a brand new column name. So let's give this a try, step by step. So first off, I'm going to create a new variable called %OntarioGrads, and I'll say this is equal to grads B Ontario column. So I've grabbed a copy of the Ontario column. And now I'm going to say %OntarioGrads equals %OntarioGrads divided by the number of Canadian graduates. So if I run this code as is, if we look at %OntarioGrads, we now have a new column, which is the number of Ontario graduates as a percentage of total Canadian graduates. But we have not yet added this to our original data frame. We still have our 3 columns. How we do this is we say grads B %Ontario. So I'm specifying a new column by just putting in whatever column name I want. In this case, I'm going to say %Ontario, and I'll say this is equal to %OntarioGrads. And if I look at grads B, look at that. We have 16 rows, 4 columns, and we have our percentage of Ontario grads. Here's our computed column. So that's 3 issues down. We've scoped our data from 2000 to 2015. We've computed the percentage of total Canadian graduates from the province of Ontario. And we've created some user-friendly column names. We have 2 challenges to go. We need to remove the Canadian undergraduates column, and we need to export our cleaned data to a new file. In the next video, we'll see how to drop columns.